Welcome to the 101 Accu-rate Hydraulic Calculation Systems. There are two systems to calculate. One is the hydraulic graph and the other is the calculations of the sprinkler system. When a contractor bids on a job, the value of the water supply must be known. The contractor is often charged through the job bidding documents to know these elements. They are displayed in the 101 Accu-rate Hydraulic Calculating System. Each element of work is listed in the following sections. Section A, the job name and the person making the study. Section B, system design. Section C, exterior water data. Section D, system details. Section E, calculated area. Section F, hydraulic calculation of the sprinkler system beginning with the most remote sprinkler. Refer to NFPA 13, Chapter A23, Plan and Calculations for detailed instructions. To make the hydraulic graph, install the data requested in Section A through E of the 101 system. Go to the field and select the two fire hydrants, one on the left and the other on the right of the proposed connection. Select one of the hydrants as a pressure hydrant. Choose the second hydrant as the flow hydrant. Note both hydrant flow outlets elevations to the building first floor. Remove the cap and install a pressure gauge. Read the static pressure and note it on cell E22 of the calculation form. Go to the flow hydrant and remove the cap. Install a reducing coupling for the 2.5-inch pitot nipple. Install a pressure gauge on the pitot nipple. This should be an oil-filled pressure gauge to handle any vibration. This arrangement will match the maximum water demand needed for most systems. At the end of the pitot nipple, install a 2.5-inch hose monster to avoid damage to the surface or auto that may cross your stream. Open the flow hydrant to the last turn to maximize the full flow. Read the pitot pressure and note it on cell A23 of the calculation page. Someone should be reading the residual pressure gauge and then give you the sign to stop the water flow. Close the hydrants slowly to avoid damage to the main or hydrant. These are very important instructions. Once this data is entered, the program will be calculated the GPM flow in cell E28. On the hydraulic graph, place a dot on the left pressure scale to represent the static pressure of 65 psi. On the same graph, place a dot on the left pressure scale at 60 psi for residual pressure. Choose a scale at the bottom of the page. Then install a vertical line as far right as the page will allow to represent the GPM calculated. Extend the vertical line past the residual pressure horizontal line. Transfer the residual pressure dot to the GPM line representing the residual pressure. Draw a sloping horizontal line between the static pressure dot and the residual pressure dot on the vertical GPM line. The estimator engineer will place the system water demand in gallons per minute and the pressure per square inch on the graph. If the water and pressure demand is above the sloping horizontal line, a fire pump must be considered or the pipe size may be increased to lower the demand pressure. If the system GPM and pressure demands are below the sloping horizontal line, a fire pump will not be necessary. However, the permit agency may require a change in the C factor of the hydrant or a percentage decrease in your demands. Perform the system data requirements asked for in Section E. Go to Section F to calculate the sprinkler system's water flow and demand pressure. From this, the calculations begin at the most remote sprinkler if this group of sprinklers is greater than 6 sprinklers. The following calculation must be applied. Density area to the power of 0.5 multiplied by 1.2 divided by the distance between the branches. In this system, the answer is 5.65. Increase the number of sprinklers calculated on this branch or any branch like it to 6 sprinklers. To complete the calculations, follow the instructions found in the NFPA Manual 13. Follow these instructions from the most remote sprinkler back to the exterior water main connection. Now you can bid the job with confidence. This program includes a study in light hazards with steel pipe and CPVC piping, ordinary hazard group 1, wet and dry, and ordinary hazard group 2 wet, grid system and fire pump piping. All piping friction gain is calculated with the Hazen-Williams formula. Share this information with the design engineer. Good luck.